the speed were increased by 10 miles per hour, a 420-mile trip would take 1 hour less time. How long will the trip take at the slower speed? So we have our chart, distance equals rate times time. We need to figure out what we're looking for, what our categories are. So how about original and then the new? Original trip, and then if we change our speed, what is the new trip? Okay, so the first thing we do then is we try to figure out what our variable is. So number one, what are we looking for? Okay, we always go to the question. It says, how long will the trip take? How long is time? So we're looking for time. So the first thing we're going to do is we're going to fill in the column for time. So we're going to fill in this first. So we have two columns, the original time and then the new time. So we need one in terms of the other. So if the speed were increased, it takes 1 hour less time. So if the original time was x, the new time is shorter by 1 hour. So x minus 1. Okay? Then number two, we're going to fill in the constant stuff. We're going to look for information in our problem that doesn't change. This should be in a column. So 420-mile trip. Okay, that doesn't change. 420-mile trip, that is distance. So original distance is 420. New distance is still 420. They don't have to be the same. In this case, they are. Okay, so that was step two. And then the third thing we do is we stop reading the problem, and we're going to use what we know about distance, rate, and time, the relationship. Okay, we know distance equals rate times time. We're going to fill in the remaining column. In this case, we are going to fill in the R column. So we need to solve this for R. To do so, we'll divide both sides by t. This will cancel. So we see that R equals d over t. So we're not going to really, it has nothing to do with this problem at this point. We're just coming up with a relationship between the column we have as a variable and the column we have as a constant. The two columns we know things about. We're trying to get R in terms of those. So R is distance divided by time. So I take the distance, 420, and I divide by the time, which is x. Take this distance, which is 420, divide by this time, which is x minus 1. So this is step 3. Then I go back to my problem and I try to come up with a relationship for rate. So using the problem, we're going to write an equation. For the last column we filled in. In this case, it was rate. Okay, so what does the problem say about rate? Okay, let's see. If the rate is speed, so if the speed were increased by 10 miles per hour, so that's what we're going to look at. Speed were increased by 10 miles per hour. Okay. Speed increased by 10 miles per hour. So which one's faster, the original or the new? If speed increased by 10 miles per hour, we know that the new is faster than the original, right? Everybody see that one's bigger? It's bigger. The rate should be a bigger number. So you can always do bigger minus smaller. So the original is smaller than the new. So the new is 420 over x minus 1. That's, I'm looking at this column right here. And I come up with an equation. 420 over x minus 1 minus 420 over x. and that should be a difference of 10 miles per hour. Everybody see that? And you always check it. Just plug in number. This you should always check in your head. So new and original, just pull numbers out of your head. I don't know, let's say the new, I don't know, if the new is 40 miles per hour, and that was an increase of 10, what was the original? 30. So if I subtract, I better get 10. Okay? And then we're going to solve this. We'll scroll down a little bit. Multiply by the least common multiple. Least common multiple of the denominators is x times x minus 1. If I multiply every single term by that, some things will cancel. Okay, I'm going to multiply by x times x minus 1 over 1. This, we're going to see that some things should cancel. X minus 1 cancels here, x cancels here. 420x minus 420x. Now this is 420 times parentheses x minus 1, so it becomes plus 420 equals 10x squared minus 10x. Okay. If you notice, the 420 x's cancel. I have a positive and a negative. That cancels and that cancels. So I get 420 equals 10x squared minus 10x. I'm going to move everything to one side. So I get 10x squared minus 10x minus 420 equals 0. I can try to factor out a 10. That's 10 times x squared minus x minus 42. I need factors of 42 that subtract to give 1. Factors of 42, 1 and 42, 2 and 21. Actually, I can see them already. It's 6 and 7, right? X minus 7, x plus 6. I need something that differs. Okay. And so I see x equals 7 or x equals negative 6. I cannot have a negative, sorry, looking for time. X was time. Cannot have a negative time. So the original x is 7 hours. So the original time is 7 hours. And the faster time, or the new time, is 7 minus 1, or 6 hours.